In February 2025, a team from Yale University dropped a fascinating piece of research into the world of science, a preprint paper on chronic illnesses after COVID-19 vaccination. This study looks at a condition called Post-Vaccination Syndrome, PVS, where some people experience persistent symptoms, such as fatigue and brain fog, after receiving the COVID-19 vaccine. COVID-19 vaccines have significantly reduced severe illness and mortality associated with SARS-CoV-2 infection. However, COVID-19 vaccines are associated with rare acute adverse events including myocarditis and pericarditis, thrombosis and thrombocytopenia, Guillain-Barré syndrome, transverse myelitis and Bell's palsy. In addition, some individuals have reported post-vaccination symptoms similar to long COVID shortly after vaccination. This condition, called Post-Vaccination Syndrome (PVS), is characterized by symptoms such as exercise intolerance, excessive fatigue, numbness, brain fog, neuropathy, insomnia, palpitations, myalgia, tinnitus or ringing in the ears, headache, burning sensation, and dizziness. Unlike long COVID, PVS is not officially recognized by health authorities, which has severely limited patient care and support. The Yale University researchers raised newfound interest on PVS in their recent paper, Immunological and Antigenic Signatures Associated with Chronic Illnesses After COVID-19 Vaccination. They set up a study that emerged from the LISTEN project at Yale. LISTEN stands for Listen to Immune, Symptom, and Treatment Experiences Now, and the project was designed to study chronic illness following infection and vaccination with COVID-19. It is linked to Hugo Health, so people from all over the USA can take part. Participants were enrolled in 2 cohorts. The PVS cohort consisted of a total of 42 participants, including 29 women and 13 men, all with persistent symptoms after vaccination, while the control cohort consisted of 22 participants, including 13 women and 9 men, who all felt well and had no chronic complaints. They also divided both groups into those who'd had COVID-19 before and those who hadn't, based on self-reports and antibody tests. The participants gave details about their health, symptoms, and which vaccine they had received, including Pfizer, Moderna, or Johnson & Johnson. Then the research team gave all the participants a blood test to look for immune cells, antibodies, and even traces of the COVID-19 spike protein. They compared the immune systems of the PVS group with those of the healthy controls, looking for clues to what was going wrong. The results were quite impressive. The types of vaccines reported were 14 from Pfizer's Comirnaty, 21 from Moderna's Spikevax, and 4 from Johnson & Johnson's J-Covden. The most common symptoms reported by participants were excessive fatigue, 85%, tingling and numbness, 80%, exercise intolerance, 80%, and numbness, 80%, exercise intolerance, 80%, brain fog, 77.5%, difficulty concentrating or focusing, 72.5%, difficulty falling asleep or staying asleep, 70%, neuropathy, 70%, muscle pain, 70%, anxiety, 65%, tinnitus, 60%, and burning sensations, 57.5%. The study revealed some fascinating findings. Think of them as breadcrumbs leading to a bigger story. The PVS cohort had fewer CD4 T cells and more TNF-alpha plus CD8 T cells. This immune imbalance suggests a dysregulated response following vaccination, possibly contributing to PVS symptoms via persistent inflammation and reduced immune regulation, as opposed to the balanced profiles of healthy controls. People with PVS received fewer vaccinations, on average only 2 compared to 4 for healthy controls. This suggests that reduced immunization may impair antibody maintenance, especially in the group who never had COVID-19, potentially exacerbating chronic symptoms via unchecked immune triggers. Reduced vaccination in PVS may reflect early adverse reactions that halt further doses, leading to weaker immunity, potentially contributing to PVS pathology. PVS patients showed evidence of reactivation of the Epstein-Barr virus, EBV, a common virus that most of us carry silently. This suggests that immune stress following vaccination reactivates latent virus, paralleling the long COVID findings, and potentially amplifying inflammation via TNF-alpha plus CD8 T cells. EBV reactivation may be a key driver of PVS symptoms, indicating a vaccine-induced immune perturbation distinct from controls. PVS patients had higher levels of autoantibodies, immune proteins that can mistakenly target their own tissues. The elevated IgM-IgA in PVS, compared to IgG in controls, suggests a unique autoimmune profile. This autoantibody pattern may contribute to the pathology of PVS, indicating immune dysregulation that differs from controls, potentially causing chronic symptoms, and requires further investigation for diagnostic relevance. In some PVS patients, the COVID-19 spike protein, which is part of the vaccines, was still present in the blood up to 709 days after vaccination. Normally, it's gone within days. Persistent spike beyond typical clearance days is consistent with long COVID and myocarditis reports, suggesting a prolonged antigenic stimulus in PVS, potentially driving chronic inflammation. In conclusion, PVS participants showed differences in immune profiles compared to controls. These include reduced circulating memory and effector CD4 T cells, and an increase in TNF-alpha plus CD8 T cells. PVS participants also had lower anti-spike antibody titers, mainly due to fewer vaccine doses. Serological evidence of recent Epstein-Barr virus, EBV, reactivation was more common in PVS participants. In addition, people with PVS had elevated levels of circulating spike protein compared to healthy controls. These findings highlight potential immune differences in people with PVS. So should you be worried? It depends on how you feel. COVID-19 vaccines have saved countless lives and the risk of serious illness from the virus. But for the few who experience PVS, it's not trivial. It is also important for those who have suffered acute adverse events such as myocarditis and pericarditis, thrombosis and thrombocytopenia, Guillain-Barré syndrome, transverse myelitis and Bell's palsy. The paper was published on Medrxiv. The author, Professor Akiko Iwasaki, and her colleagues believe that it underscores the need for further research to validate and address this condition, balancing the benefits of the vaccine against its risks. As the paper is still a preprint, it still needs to be thoroughly reviewed by other scientists to confirm the findings. In the future, the researchers may investigate: why does the spike protein persist in some people? Can we predict who's at risk of PVS before they're vaccinated? Could treatments reset the immune system in people with PVS? For now, if you're curious or concerned, talk to your doctor. The CDC website is also a good place to get the latest information on vaccine safety. Below is a timeline of the evolution of the COVID-19 vaccines, from their rapid development in response to the SARS-CoV-2 pandemic to their ongoing adaptation as of March 2025. The discussion is structured to cover key milestones, including initial design, clinical trials, authorizations, and responses to emerging variants. We'll also touch on unexpected findings, such as rare side effects, to provide a holistic view. Okay, if you found this video helpful, be sure to like, subscribe, and turn on notifications so you won't miss our upcoming videos. Leave your comments below. We'd love to hear from you and continue the conversation. Thanks for watching, and we'll see you next time.